So, in this video, I'd like to show a presumably novel way I've figured out how to make basically arbitrary polyhedra in CAD relatively simply using sketch geometry rather than solving for angles. Like a lot of people out there who are like, I'm going to make a dodecahedron. They'll tell you like, okay, well, use just 116.565. That's the number I'm reading off of the over here where it's out of frame. But what that ends up doing is by the end of your whole assembly, your whole complex assembly, the tips and edges, they start to clash and not line up perfectly. But what you'll notice with this style is even if we look very close, since we defined everything in sketch geometry, we've defined our angles in a kind of novel way that looks like fell magic right now. We've defined it in a way that it's all taken care of in the solver, and we don't need to deal with it. And since it's so simply and rigidly defined, we can say change the dimension of this guy at the very beginning, which is just in one sketch, and we can scale up or scale down the whole thing. We can do other stuff. We can just whip up an arbitrary polyhedra really fast. So I'm going to show you how we got to here and what that looks like. So I'm going to turn this back here. Just as a demo, though, we're going to say this guy and this guy, we're going to isolate them. So the basis of this idea is we're going to pick 2 points on our polyhedra that we want to make that are a nice even distance. Say here we've got these 2 points are the top and the bottom. These 2 points span 180 degrees arc because, like, say if I pick this thing up with my fingertips and I could spin it between my fingers like a basketball, we know that that is not eccentric, it's not off axis or something. You'll know it if you pick 2 wrong points, say if we pick like this point and this point, because the whole thing will kind of wobble off axis. Okay, so now we've picked our 2 points that the thing rotates in a nice symmetrical way on. What we do is we say, okay, is there a path from these 2 points that are a nice even distance that spans something that I can define in sketch geometry? And turns out there is. Okay, so we're gonna, for instance, we're gonna go through the middle of this pentagonal face, and we're gonna go through the middle of this pentagonal face, and this is just one edge. But we all know, we know that all of the edges, at least for this, are they are perpendicular, and the faces, all the edges are perpendicular to a line that goes from the midpoint to the origin, and all the faces are normal to a line that goes from the middle of the face to the origin. So out of this, we can get some kind of cool sketch geometry. So let's just to show you how fast this is. I'm going to kind of fuck up a couple times probably, but like I've really struggled with this, and I thought I was clever a bunch of times, and then I found this, and it's just like worlds easier to just define whatever we want. And just to show you this kind of stuff works, here's a buckyball I made with the same thing, and instead of the pentagons, like I guess we could do this with the buckyball and say, okay, well that edge here goes full 180 up to here, but like that's harder, and we can see that this is nice and square with this edge, so we can just span a 90-degree arc from here to here. So just to show you like that this works, let's do it up on a buckyball, and like we're gonna have like look, here's our finished thing, and it has like, I don't know, I did some dumb stuff here just to like kind of propagate the pieces all the way to the end, but like you can be smarter than that. But like by the time you get here using other methods, you're going to be pretty sad, and like all your stuff's going to self-intersecting. But so, and again, like here's the same idea where we have this face that's normal. We've kind of rotated, revolved into this cross-section piece. So yeah, let's do that again, just from scratch right now. We're gonna hide all planes. We're gonna center this on my view window. Just for reference, we're gonna create a sketch on the front plane. We're gonna make an edge that is perpendicular to the midpoint. So this edge, we can worry about dimensioning it later. It's going to be really sort of jangly for a second and not really want to line up nicely and prettily. But you'll just have to bear with me. And like, I don't know, just find a picture of your platonic solid of choice and then like, just have a stare at it. Like, some of these things, if you can just see it in 3D, are like fairly obvious. So we see that like the midpoint of this edge, and then we go from the point to the midpoint of this other edge, midpoint of this edge to this edge, and that spans 90 degrees. You could even like look at it here. So let's do that. So we're going to do inscribe pentagon, make it 5. This edge is glued to here. Make that incident. Let's draw a construction midpoint across here. Make construction so it's a little prettier. Make this perpendicular. Make this equal these edges. It doesn't matter which edge you pick, but like now we know this edge is equal to this edge, and the solver has just figured out this distance and angle for us, and we're going to just do that again. So let's do hexagon. Good. Make it equal here. Whatever. We're going to pick this point and this point because, again, we're going to reference our buckyball and be like, okay, well, like these edges meet together and we can just slice down the middle of it. And that is the point that they intersect. And we don't care that this is out of plane. We're just worried about this bit of geometry. So we can get this for free if we're willing to sort of revolve it into, we're willing to sort of revolve it into the plane that we're working in. Again, we're going to make some sketch geometry here, midpoint to midpoint. Oh, I didn't get that. Midpoint. And like, don't worry about these things coming from the middle. And then we're just going to make this horizontal. So now we know that this. Oh, okay. So I glued that to the wrong thing, and that's easy enough to fix. And you'll see that like sometimes you'll try to put it together and it just doesn't quite work. And you can kind of define these pretty complex relationships between the faces with relative ease. Okay, horizontal. Okay, and this one is still fighting us because it's trying. It doesn't know what this line here doesn't know it's oriented to perpendicular to the origin. So as soon as we make it that, perpendicular, shift L. I think, yeah, shift L. So what we've got now, and just, I don't know, I'm gonna, just to show that this stuff is, like, if we try to, like, guess and check from, like, say if we dimensioned to one of these edges, and we just say we want the edges to be a certain width, if we want the edges to be a certain length, we're gonna have to guess and check to find the actual overall diameter. So let's just make this 200 millimeters in diameter from this point. See, and now that's going to glue together. This whole thing is like kind of rigged together, and we can see this non-driving dimension is just this random value, and like to kind of get that would be quite a bit of guessing and checking, and we can very easily go here. Let's go 300, whatever, doesn't matter. Now we're all rotated around. Yeah, CAD stuff is not for people who get nauseous easily. But you can see that I just changed this one number, and this finds this number for us, and we still get this for free. And then let's just get these pentagons into plane. I like to use a line angle, just so you can see what I'm doing. I got this line angle plane, and this is agnostic to whatever your CAD package is, as long as it's like reasonably well featured. I have a personal vendetta against OpenCAD. What's it called? FreeCAD. But I don't know, maybe not personal. It just doesn't work in 4K screens. Okay, so this one, and make sure to just pick the that normal axis line. Great. So now we have our plane. Just so I'm sure you I'm being a good doobie, I'm going to label my sketch. This is the pentagon. This is the pentagon plane. I'm going to make the hexagon plane over here. Line angle 90 degrees. 90 degrees, and just to show you that it's where I meant to put it, we're going to rotate it around a little. Cool. Buckyball. Now we're going to sketch on the pentagon plane, and what are we going to draw on the pentagon plane? We're going to draw a pentagon. We're going to use just this point and this point. That's all you need. And we're going to draw a inscribed pentagon. It's going to try to grab you onto really random stuff. We're just going to glue this to we're just going to take this and we're going to glue it onto this one. Cool, good enough. And let's hide the pentagon plane for now. And we're going to do the same thing for the hexagon plane. The hexagon plane, we're going to use just this point and this point. And that's enough to get us where we want. We also use some other stuff, but like this is good enough. Let's go pentagon. And it's going to try to glue you to some random. I feel like if you're watching this, I don't really need to explain some of the pieces here. Okay, so what we've done is we've kind of used the geometry from the basis sketch. I'm probably using that word wrong. To the sketches that are actually in plane. We've rotated them back from. We've rotated them back from the slice plane, which like just we could rotate them back from the slice plane to the actual angle of the plane. So now we have those. We're going to click done. I find a really nice tip here is to I was doing some kind of cursed stuff with like 3-point planes and slicing, but what you can do is you can just take a loft, and at least in Onshape you can go loft from this to the point. I don't think it works the other way around, but you can go loft to the point all day. And we're going to do loft to point on the hexagon. Loft to the point. Cool. And let's just start at the top here, since or let's make sure to not hide this. It's important to keep track of like this guy. We're going to use this initial axis a lot because just make sure they're not adding. Yeah, if we add, we kind of get all these. Let's just make sure they're not kind of glomming all together. And we can start doing some things here. I really like to kind of propagate, for lack of a better word, these pieces around. We can say, I'm gonna do a circular. You can either use circular patterns. Circular patterns are sort of mirrors in this case because they're rotationally similar. Let's do a circular pattern of this for 2 around here. And you can see that when I do that, we're sort of just, we could also do a, for example, we could do a plane on this line, but have it a mid-plane line. And we could also sort of mirror across that, but rotate around works just fine. I'm just going to delete that because we don't need it. Let's see. And if we wanted to get this guy up here, let's propagate this one around this axis 5 times. And then we can kind of do some fun stuff with all of these that we just created. Make sure it's not adding them together. Kind of fights you a little more. Yeah, and I'm just gonna kind of like work down from top to bottom. And let's say circular pattern of this around the central axis. And you can even select this other one here. So now we've gotten those on the other side. Like, it'd be much harder to like create a, I guess we could still use that initial plane that I already deleted, but you kind of get the same thing. But still notice that our feature count is actually quite low still. Yeah, and here we could go. And like maybe if you pick a bit better place, like actually I'm gonna pick this is the new up because then I have lots of sort of rotational symmetry. We're gonna pick this. It's a little bit of a puzzle, but like it's so easy to change things that like it's worth just kind of working out a little geometry puzzle. And here, look, you can just grab this one. Circular pattern, this guy around. I recently started using tab, which feels kind of magical. Tab to kind of go from between these 5. We're going to skip this instance that already exists, the slightly darker one. Wow. Cool. And I think there's some argument for this probably could. Okay, so I'm going to do something kind of weird. I think I'm sort of eyeing. There's actually a line of symmetry that I can rotate this whole thing around and kind of clone the top and the bottom. But not really seeing it right this moment. You know what? Let's go for it. Circular pattern. I'm gonna just kind of like pick one. Is this it? 2? Oh, okay. Oh, it's the midplane of that one. Okay, cool. I just because I'm kind of already on it, my teeth are in it. Just draw a line here. Cool. Good enough. Now we can do a circular pattern on this whole situation on this axis. And bucket YOLO, there's our buckyball in our full buckyball in let's count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 sketch features or pieces of design history. I don't know what it's called. And then we can do cool stuff like this, where we're like, oh, well, now that we have a buckyball that's a solid, we can pick a front plane. It doesn't matter. Cool. Let's pick the right plane. Let's hide all parts for a second. We're just going to do a circle. Make a line. Incident. And just because we can do something like this, where we're gonna revolve this piece around here, intersect, merge with all, and show all parts. And basically for free, I don't know, I added 2 to the 14. I don't really want to call it counted right now, but okay, we got 20 features, including these guys to start with. Now we got a spherical projection of a buckyball in 20 design features, and I can change the diameter of this really easily. These are all individually pieced out. And again, like, since we defined our things so simply in the beginning, I can change this guy, and rather than kind of fighting to compute a whole lot, we just change the diameter of the whole thing in kind of one motion without our design history breaking. And like these circular patterns, like, they look a little messy, but like I think you're going to kind of struggle to find and define those sketch planes from scratch when you can just like, oh, that edge works, whatever. And like you can do this for other stuff too, as long as you can find this, like, see, this point to this point. This is a nice 90-degree arc. For the dodecahedron over here, I found that it's a little harder to kind of find that 90-degree arc. So you have a nice, there's actually a nice path that goes from here, the bottom, along an edge, along the middle of a pentagon, and then along the middle of the next pentagon. And that arc segment looks like this, where we've taken those planes and we've rotated them in plane with the sketch plane, with the initial kind of slice, as if it did like, you can do this with like revolves, but this just kind of do that step in your head works out really well. It just works. And as long as you can make sure your planes are normal, I think this is going to do weird stuff if you're trying to do solids that don't have planes that are normal to a perpendicular line. You're going to have to kind of tweak that. And you could even do weird stuff like this, where, like, I don't know, if you put this plane off, you'd probably create a wholly different, like, say if this angle from this line to this line was different, and like you could kind of change that path somehow. Like, you can start doing some pretty strange stuff, and kind of define arbitrary polyhedra from sketch geometry. Like, this looks messy, but it saves so many steps. Like, we're working down this arc here for the dodecahedron, because it spans a 180-degree arc. With the buckyball, we are spanning a 90 degree, we're going from the midpoint of this guy up here down to there, and that's a 90 degree arc. So we go middle of that, across this pentagonal face, across this pentagonal face, that covers a 90 degree arc. And from that, as long as we can make our sketch geometry play nicely, and we know that this pentagonal face is normal to, perpendicular to the center point of that pentagon from the inscribed pentagon, as long as we can keep that face normal, perpendicular, this one is normal and perpendicular, all these edges are the same, they're all glued to the same thing, the sketch, the solver, figures out those angles for us, and it just fucking works. And like, I haven't found anything better, and then we can, and like, with all of this, then we can just start doing kind of cool, clever things, and now we have our spherical buckyball. And spherical buckyball in like 16 sketch steps, design history steps. I would challenge. I mean, I'm eating up most of the sketch history with like these guys, and there's probably more clever ways to do that, but like this just worked enough that I don't know, proofs in the pudding or something. Anyway, that is, I think I'm gonna call it for now. My name is Aaron, and this is a clever way of solving for arbitrary angles on polyhedra that you've found on the internet or whatever. As long as your faces are normal to the middle of the face, to the origin, like, you can do this. I think this is way easier than doing it using angles. And the angles route just doesn't work. It's like, if you try to do this with angles, like, you'd look over here and all these angles are like self-intersecting and exploding. So it's a little abstract. It's a little different than what you're otherwise going to do, but I haven't seen any documentation of this technique, and this is just what I do now when I make dodecahedra. Yeah, my name is Aaron. Thanks for watching my thing, and